Hello students, in this class we are going to learn how to differentiate a parametric function. So in parametric form, a function x and y both depend on a single parameter. So suppose x is some function of t and y is also some function of t, and we are interested to find dy over dx. So first we differentiate x with respect to t, and it gives us dx over dt, and this is nothing but derivative of f of t with respect to t. Then we differentiate y with respect to t, so this gives us dy over dt, and this is nothing but derivative of g of t. Let us say here we get g prime t. Now, after getting dy over dt and dx by dt, we are interested to find dy over dx. So dy over dx is nothing but it is simply dy over dt divided by dx over dt. Let us understand this through some question. Say x is simply 2t cube plus 4, and y is say 4t square plus 5t plus 7, and we are interested to find derivative of y with respect to x. So in order to find dy over dx, first let us differentiate y with respect to x. First let us find derivative of y with respect to t, because uh, y is some function of t here. So dy over dt is 4 times of derivative of t square. Let us use power rule. So derivative of t square with respect to t gives us 2 times of t, plus derivative of 5 times of t gives us 5 times of 1, and derivative of a constant is 0. So dy over dt simply becomes 8t plus 5. Now let us differentiate x with respect to t. Here x is nothing but 2 times of t cube plus 4. So let us find dx over dt. Dx over dt gives us 2 times of 3t square, and derivative of t is simply derivative of 4 is simply 0. So dx over dt is simply 6t square. So now, since we already find dy over dt and dx over dt, let us uh, write dy over dx. And this is nothing but dy over dt. So dy over dt is simply 8t plus 5. So 8t plus 5 over dx over dt. This is 6t square, and this is our simple answer. Let us see few more questions to understand it better. The x is 4t and y is 4 over t, and we are interested to find dy over dx. So first, let us find dy over dt. Dy over dt is nothing but 4. Derivative of 1 over t is simply minus 1 over t square. And let us find derivative of 4t with respect to t. So dx over dt is simply 4. Derivative of t with respect to 1 with respect to t is simply 1. So finally dy over dx is minus 4 over t square divided by 4. And 4 get cancelled, and finally we get 1 over t square. Let us see one more question here. Say x is a times of theta minus sine theta, and y equals to a times of 1 plus cos theta. And we are interested to find dy over dx. Please remember, here x and y depend on parameter theta. So let us find dx over d theta and dy over d theta, and finally dy over dx is nothing but dy over d theta divided by dx over d theta. So first let us find dx over d theta. Here a is a constant. So write as it is. Derivative of theta with respect to theta is 1. Derivative of sine theta is simply cos theta. So dx over d theta is a times of 1 minus cos theta. Now let us find derivative of y with respect to theta. So derivative of 1 is 0. Derivative of cos theta is negative sine theta. So dy over d theta is simply negative a sine theta, and dx over d theta is simply a 1 minus cos theta, and we know 1 minus cos theta is simply 2 sine square theta. So we can rewrite this as a times of 2 sine square theta by 2. Let us plug these value to find dy over dx. So dy over dx is minus a sine theta divided by 2a sine square theta by 2. Let us simplify this, but before that a get cancelled, and we can rewrite this sine theta as 2 sine theta by 2 into cos theta by 2 over 2 sine square theta by 2. So 2 get cancelled, sine theta by 2 get cancelled, cos over sine is cos. So we end up getting negative cot theta by 2. So finally dy over dx is negative, dy over dx is negative cot theta by 2. Let us see the final question. Here x is square root of a raised to the power sine inverse t, y is square root of a raised to the power cos inverse t, and we want to prove dy over dx equals to negative y times of x. Before starting this question, let us know a couple of important points, like derivative of a raised to the power x is a raised to the power x log a. Also, derivative of sine inverse x is 1 over square root of 1 minus x square. Also, derivative of cos inverse x is negative 1 over square root of 1 minus x square. We use these formulas while finding derivative of x and y. So x is this much. We can rewrite this as x square equal to a raised to the power sine inverse t. Now differentiate both sides with respect to t. We get 2x into dx over dt equal to a raised to the power x. Derivative of a raised to the power x is a raised to the power x log a. So derivative of a raised to the power sine inverse t is simply a raised to the power sine inverse t into derivative into log a. We also differentiate sine inverse t now, and we know derivative of sine inverse t is simply 1 over 1 minus t square. Now this is done. Let us say this is equation 1. Now square this one also. So we get y square equal to a raised to the power cos inverse t. Now again differentiate both sides with respect to t. We get 2 times of y into dy over dx equal to a raised to the power cos inverse t into log a into derivative of cos inverse t is simply negative 1 over square root of 1 minus t square. This is equation 2. Now divide equation 2 by equation 1. We get 2 times of y. This is dy over dt. Sorry. Now 2 times of y dy over dt divided by 2x dx over dt equal to log a get cancelled, 1 over square root of 1 minus t square get cancelled. Second equation is negative. First one is positive. So we get negative sign. Here we get a raised to the power cos inverse t divided by a raised to the power sine inverse t. Please remember a raised to the power sine inverse t is nothing but x square, and a raised to the power cos inverse t is nothing but y square. So let us plug this value here. Here 2 get cancelled. Here a raised to the power cos inverse t is simply y square, and this is simply x square, and this is y over x. dy over dt divided by dx over dt is simply dy over dx. This x get cancelled, this y term get cancelled. So finally, we can say dy over dx equals to negative y over x. So that's how we differentiate parametric function. Hopefully all of you are able to understand this. However, if there is any problem, then let me know in the comment section. Thank you.